So torque, right? Shh. Torque is a force, right? Torque is a force, but more technically and more specifically, torque is a force that causes rotation. Okay? So it causes rotation. So it causes things to rotate around some axis of rotation or center of mass, depending on what is happening with the object. So if we're talking about like a wrench, right, the axis of rotation would be the bolt that, or the nut that the wrench is attached to, right? If we're talking about like that space shuttle, the axis of rotation is the center of mass of the space shuttle. If you throw a hammer, right, the center of mass is somewhere closer to the head of the hammer, right, and it spins around that point. Right, so it spins around that. If you throw it like this, it rotates like this, and it's about that center of mass. The interesting thing is that while it spins like that, the center of mass actually travels like it was a projectile. So if you threw it like this, it would actually, the center of mass would travel like that as it goes around. So
I feel some really complicated problems coming up. No.
Yep. So this force causes rotation. Now, we talked previously about like pushing on the door, right? And if we push on the end of the door, right, we've got the axis where the hinges are. And if we push directly on the hinges, or directly this way, right, we don't cause any rotation, okay? Because you have the hinges right here, and your force is going this way, so it's going directly through the axis. Does that make sense? So if your axis is right here, and you're pushing directly through that axis, it's not going to cause any sort of rotation. Okay? But if we push here, right, we get the door to rotate. And this doesn't have a door return, but if we push on the other door over there that has a return on it, we know just from experience that if we push on something out here, it's a lot easier to get it to rotate than if we push closer to the hinges, right? Okay? So what we've done is when we do something like this, we slide out farther away, we have increased the radius, right, or the distance from where the force is to the hinge. Okay? So if we look at that, torque depends on two things. Give me a second. Okay? Torque depends on how far away we are, right? The radius, which is the distance from your axis to your force, and the force with which we're pushing. Okay? And if you think about opening a door, there's two things you can do. You can push harder on it to open it, or you can push farther away from the hinges. Okay? If you are, let's say you get a flat tire, right? And you need to take the lugs off. Well, you can get a wrench and you can pull on it, right? And you can do that, and it may not work. So what mechanics may do is they may have a big, long pipe, right? If they have that long pipe, they put the pipe over the wrench and they come out here and they pull on it, right? So what they've done is they can only apply so much force, whatever is humanly possible for them. Say it's the maximum amount. Well, the only other way we can increase this torque, which is going to cause rotation of the lug nuts, is if we can increase the radius. So sometimes if your hammer won't drive a nail, or if your wrench isn't big enough, right? Or if your wrench, you're not strong enough to apply enough force to cause something to spin, if you can increase the radius of it, right, you then are increasing the torque. So you may see someone that has like a 3-4 foot pipe that fits over a wrench, and then they go out here and they just rip on it like that, and it'll open it up because we've increased the torque, because we've increased the radius, okay? Give me one more second. Now, when we push on a door, right, usually we push on it like this, right? So if our radius is here, and we push this direction, we're pushing perpendicular to the door, right? Okay? Perpendicular to the radius is what we really should say. Now, we can open it by pushing it sideways, right? Pushing at an angle, but it's a lot harder, right? If you think about it, if we're pushing at an angle, okay, we're going to have some part of it, the components of the force, some of it is going to be perpendicular to the door, some of it's going to be parallel to that radius. Does that make sense? And we've already seen that if we push parallel to the radius, it doesn't create any torque. It's always that perpendicular piece that creates the torque. Okay? So what we can say then is that they need to be perpendicular to each other. Or more simply, we can say that tau is equal to r perpendicular times the force. Okay, yep, this is the Greek letter tau. I'm putting a squiggly top on it. Okay? Now, most times, the perpendicular part of the force is going to be sine. So it would be like RF sine theta. Most times. There are times, though, where you need to use cosine. So you need to pay attention to your orientation of the forces and make sure that the force and the radius are perpendicular to each other. Okay? Caitlin, you had a question?
Yeah, when you push on the door, is it because the center of the mass wouldn't be the hinge, right?
But it's right. It's so the center of mass of the door is probably somewhere in the center, but because it's being allowed to pivot on these hinges, that is where it's going to rotate on. So if we just had it off the hinges and it was just standing there, and we gave it a push or we did something to it, it would rotate around that. Okay? Or if it sat on the floor, really the friction between the door and the floor would create the axis of rotation. Okay? Was that your question too, Bobby? Okay? Awesome. All right.